Hello students, मैं हूँ Dr. Preeti and I'm back with another revision video continuing with our revision for light chapter. We have already seen about the mirrors and today we are going to revise convex lenses. In convex lenses, we are going to practice all the ray diagrams. Have you ever seen concave and convex lenses? Yes, you all have seen that. I'll tell you where. So, first let's start with convex lenses. I hope you know the basic terminology. A convex lens is one which is thicker from the center. Remember that. I have seen that some students, while drawing the convex lens, they forget about that and they draw a concave lens. So, don't mess up with that. A convex lens is one which is thicker from the center part. This is the principal axis. In lenses, we define two focal points. Why we define two focal points? Because a light ray that is coming from the right side will converge at the left side, and if a light ray is coming from the right side, it will converge towards the left. Okay, it's vice versa. So if the light rays are coming from left side, it will converge at right side. If the light rays are coming from right side, they will converge at the left side. So that's why lenses always have two focus points, f1 and this is f2. The midpoint of the lens is known as optical center. Okay. Now, if if this lens is taken out from a spherical structure, so that spherical structure should be having a center, and that center is known as, it could be represented by C2, or it's known as center of curvature. It could be represented by C2, or we usually represent it by 2F2. Okay, 2F2 and 2F1 are the centers from which these spherical structures have been obtained. This is the principal axis that is passing through the optical center as well as both the focus points. Okay. Now, the rules. First rule is that if a ray of light is coming parallel to the principal axis, after refraction, now what will be happening is refraction. So, after refraction, it will bend and it will pass through the focus. Okay. Remember one rule that will make you memorize all the ray diagrams in a better way. The light ray will be bending towards the thicker part of the lens. Okay. So in concave lens, when we'll talk about the concave lens, just remember sometimes you mix up with the diagrams of concave and convex. That's why I'm telling you that together. This is a concave lens. So in a concave lens, the thicker part is this. If a light ray is coming parallel to the principal axis, it will be bending towards the thicker part of that concave lens. And in a convex lens, the thicker part is the middle one. So the light ray will be bending towards the thicker part of the lens. मोटा वाला जो part है उसकी तरफ light ray bend होगी, बस ये याद रख लेना, है ना? Because I've seen that sometimes it happens that when you draw the ray diagrams for concave lenses, sometimes the students draw a parallel line and make it converge that. It's not a converging lens. Concave lens is a diverging lens, and convex lens, this one is a convex lens, it is a converging lens. So light rays when fall parallel to the principal axis will pass through the focus. I hope this first rule is clear. Now the second rule is just opposite of the first one. Very easy to memorize, just opposite of the first one. So what is it? Here again we have the principal axis, optical center, f1, f2, 2f1, 2f2. Okay, f1 and 2f1, f2 and 2f2. The second rule says that any ray of light that is coming passing through the focus, if it is passing through the focus point and coming to the lens, then after getting refracted from the lens, it will go parallel to the principal axis. Okay, it's just the opposite of the first rule only, so it's very easy to memorize. And now the third rule, again a very simple one. Any ray of light, if it is passing through the optical center, it will go undeviated. It will just pass on straight, it will not diverge. It will go undeviated. Okay? So using these rules, we are going to draw the ray diagrams of convex lenses right now. So the first condition is always we place the object at infinity. So how we place the object at infinity? Any ray of light that is coming from infinity, that will be coming parallel to the principal axis. This is our principal axis. Any ray of light that is coming parallel to the principal axis means that the light rays are coming from infinity. Okay, so light rays are coming from infinity. After passing through the lens, they are going to converge towards each other, and they will be passing through the focus. Which focus? F2. So they will be passing through F2. Fine. This is the first condition. When the object is placed at infinity, the light rays are passing through F2. Okay. Have you ever witnessed such a condition in your daily life? You all must have seen that, and you all have seen this lens also. This lens we commonly use as a magnifying glass. You must have used it in your childhood to burn a paper using the light rays of the sun. ठीक है, कभी ना कभी तो बचपन में किया ही होगा, लाइट रेज, सन की लाइट रेज को सारा कन्वर्ज कराया होगा, and you must have focused the light rays of the sun to one point, and you must be amazed to see that even the paper starts burning with that, because all the sun rays are getting converged at the focus. So if you just place it in such a way that all the sharp rays are getting formed at one point, you make out that this is a focus. You never knew it is a focus, but now you know that. So that is a focus point where you have converged all the light rays and you have got the paper burnt. Okay, so that was the same lens that you have used in your childhood to create that burning effect of the paper. Okay, for lenses also we need to write the same points, 4 points that we used to write for the mirrors. First is the position of object. Here it was at infinity. Position of image, it is at focus. Nature of the image, when the light rays are actually intersecting each other, that is always a real image, and a real image is always inverted. So it's a real inverted image. Fine. Next is the size of the image. You can see it's a point size image, है ना? You must have observed that on the paper which you have burnt. So it's a point sized image. Now the second condition is when the object is not at infinity, we are going to bring the object closer. As we have seen for concave mirrors, slowly we were bringing the object closer. So we are going to do the same thing here also. Now we are not placing it at infinity, but we are going to place it at beyond 2f2. Beyond 2f1 we are going to place our object. This is f1, 2f1. Beyond 2f1 we are going to place the object. One of the light rays coming parallel to the principal axis, after refraction, where it will pass? That will pass through f2, second focus. Always remember, in a lens we can place the object on any side, but conventionally we always place the object towards the left side. Okay, as a convention, just as a thing, we have to need to follow some rules, na? So just as a rule, we place the object towards the left side only, whether it's a mirror or a lens. One of the light ray which is passing through parallel to the principal axis, after refraction will pass through f2. Another ray of light that is passing through optical center will go straight, undeviated, and it will just pass through like that without any deviation. No one can bend this light ray. Actually I have bent that. Okay, we need to make it straight line. Okay, yeah. So here is the image formed. Okay, take proper measurements to get the exact ray diagrams. If you take proper measurements, means whatever distance is there between O optical center and F1, suppose it's 3 centimeter, the same 3 centimeter distance should be there between F1 and 2F1 as well. Similarly, this side also, whatever is the distance between O and F1, take the same measurements this side also. If you take the proper measurements, then you will never make any mistake in drawing any ray diagrams. Okay. So the image formed is between F2 and 2F2. Automatically that will be formed. If you use the rules, just use the rules, no need to remember anything. Automatically the ray light will be converging at that point only. And wherever is the point of intersection of the light rays, that is the point where image is formed. If the object is represented by AB, the image is represented by A dash, B dash. What is the position of the object? It's beyond 2F1. And what is the position of image? Between F2 and 2F2. What is the nature of image? You can easily see that it's a real and inverted image, and its nature is small size. If you take proper measurements, you must have got that it's a smaller image formed in by this lens. Okay, so now we are again going to bring our object even closer as we did in case of concave mirrors. So now we are going to place our object at where? We are going to place it at 2F1. Okay, place the object at. Now I'll try to take the same measurements, 2F1. Okay, now in this condition also we are using a trick. Like in center of curvature we used a trick now. Similarly for this ray diagram also we are going to do some cheating. We are going to use a trick. And what's that trick? When the object is placed at 2F1, a same sized image is formed at 2F2. Okay, so what we are going to do is one of the light ray, even if we use the rules, we are going to get the same ray diagram only. But for this condition, we need to remember that, so that we don't land up with even um, a ray diagram that is wrong by 1 millimeter. Okay, we shouldn't get it even an a millimeter this side or that side. So exactly at 2F2, what we are going to do is we are going to draw a same sized image, whatever was the size of the object, same sized image we are going to draw at 2F2. Now what we are going to do, we are going to join the point here to here. I'm making it to pass through F2 only. Okay, or wherever it passes, we will mark that point as F2. Okay, another ray of light passing through optical center will go undeviated and it will go straight and it will pass through that same line. So we'll just make it join from this point to this point. From the starting of the object to the image, we will be joining the lines and we will definitely be getting this line. Okay, I hope you are not just following the video, you are just drawing it along with me. Always do that. Always be ready with your things, pencil, scale, everything, and just draw the ray diagrams with me so that you are practicing it by yourself and you can just check your ray diagrams with that. Okay, so this was our next condition. Now here what we'll say, what's the position of object? It's at 2F1. And what is the position of image? It's at 2F2. What is the nature of image? It's real and inverted and size is same size. Okay, now again हमारा object और पास में आने वाला है as we used to bring it for mirrors. So it's going to come one step ahead and now it's going to come between F1 and 2F1. But before we draw this ray diagram, just recall when we place the object between beyond 2F1, where was our image formed? Just go back into your diagrams, have a look. It was formed between F2 and 2F2. And now let's see, when we are placing the object between F1 and 2F1, what is the position of our image? F1, 2F1, we are placing the object here. A ray of light passing parallel to the principal axis after refraction will pass through F2. Another ray of light that is passing through the optical center will go undeviated. It's getting deviated. It goes undeviated and goes off straight. Wherever the two light rays are meeting each other, that is the point where the image will be formed. Okay, so it's going too far away. So the image is an enlarged one. A real inverted enlarged image is formed beyond 2F2. In practical life, have you ever seen such a sort of image? Yes, you all have seen that. When you go for a movie, in a movie hall, the image that you are seeing on the screen, that is actually the image formed using a convex lens. The object is placed, that is the roll of the screen is played between F1 and 2F1, so that you get a huge and large image of that from that projector on the screen of the movie hall. Okay, similarly, in a projector in your classroom, in the school, that we see a projector, so that is also based on the same principle. That is also using a convex mirror, convex lens, sorry, convex lens, and the image is formed beyond 2F2, and so it is a real inverted enlarged image. Okay, so we should know practically where it is there in our life. It's not given in NCRT. We need not write that in our exams. But science is just not about the books only. It's about knowledge. It's us surrounding us. So whatever are the day-to-day life examples, wherever the things are there around us, that we should know. That becomes very interesting then. Okay. Now next we are going to bring the object even closer, and we'll be getting the object at F1. We are placing the object at F1. One of the light ray coming parallel to the principal axis after refraction passes through F2. Another ray of light that is passing through the optical center will go undeviated, will go undeviated, and it will go till infinity. It will reach infinity. Okay, so the light rays are parallel to each other, and that is why we are saying that the light rays are going to go till infinity. Okay, so when the object is placed at F1, the image is formed at infinity. Means whenever we have to send the light rays to a great distance, then we can use this concept. Okay, in searchlights or wherever we want to send the light rays to a great distance, we can use a convex lens and place the object at the focus, so that the parallel beam of light will be formed and that will be going to a great distance. Okay, now next, what are we going to do? We are going to bring the object even closer. In this condition, what we will write? The object is placed at F1. The image is formed at infinity. So when the object was at infinity, sun, the image was formed at focus. Do you remember that? And a burning of the paper. And now when the object is at focus, the image is formed at infinity. Okay. So these conditions are always the reverse of each other. Similarly, when we place the object between F1 and 2F1, the image was formed beyond 2F2. And when we place the object beyond 2F1, the image was formed between F2 and 2F2. So it's all the reverse of each other. Okay, if you memorize one thing, the other one will automatically be there in your mind. Now next one is when we place the object between optical center and F1. We are placing the object very close to our lens now. We are placing it between F1 and optical center. One of the light rays that is coming parallel to the principal axis after refraction will pass through F2. Okay. Another ray of light that is passing to the optical center is going straight. It's not getting bent. It's going on straight without any bending. But you can see these two light rays are diverging from each other. They are going apart. Okay. So they will not meet anywhere in this side. But we can make them meet somewhere on the same side of the object. So let's trace these light rays whenever they are not ready to meet each other. Now we just trace them in the backward direction. We always do that, except for the light rays which are parallel to each other. Okay. So what will happen when we just trace them in the backward direction? We find that they are meeting each other, and they are meeting on the same side as that of the lens. So the image is formed on the same side as that of the object. We don't represent where it is formed exactly, not the position, like it's between F1 or 2F1, anything. We are not going to represent that. We don't say that because depending on the position of the object, it varies. So we just say that the image is formed on the same size as that of the object. The nature of the image is, are the light rays actually intersecting with each other? No. So whenever they are not intersecting really, we call it as a virtual erect image. So the image formed is a virtual erect image, and that is an enlarged image. Okay. Have you ever seen such a image? You all have seen that. You always have enjoyed that, and that is why we call a convex lens a magnifying glass. You must have seen the words through a convex lens. So when you observe the words through a convex lens, something which is written very, very small alphabets, that also appears to be bigger. So actually that is the image of the alphabets that you are observing through a magnifying glass. So this last condition is representing our magnifying glass only. Okay. So that's all about the ray diagrams of convex lenses. I have tried to move that very quickly so that it doesn't waste your time also. Okay. So that's all for today. That's all for convex lenses. In the next video, we will discuss about the concave lenses, the ray diagrams, and one thing. One last thing I want to ask you all, just answer me in the comment section if you remember that. Why the light rays that are passing through optical center that don't bend? Why they don't bend? Why we are saying that the light rays that are passing through the optical center don't bend? Why is it so? Can you give me the reason? Then please send your answers in the comment section. I would be waiting for a reply. Okay? Goodbye.